with question 7, we are going to check for true or false. So at the moment I've got a statement here, 7 is less than 9. True or false? Obviously that's true. However, if I was to write something like 10 is less than 9, then obviously that is false. Okay, that's not true. So going back to our what we have here, we have 7 is less than 9. What would happen if we minus 5 from both sides? If we minus 5 from both sides, okay, we will get 2 and 4, isn't it? So if you take away 5 here, you get 4, and if you take away 5 here, you also get 2 here. So is this still true? Is 2 still less than 4? Yes, it is. So this is true, this is true. 2 is less than 4. So what would happen if we multiply both sides by 3? If we multiply both sides by 3, we will get 12 on the right hand side, because if you times that by 3, you get 12. If you times that by 3, you get 6. Is this still true? Is the statement still true? Is 6 less than 12? Yes, it is. So the statement is still true. What if I divide both sides by 2? What if I divide both sides by 2? I will get 3 and 6, sorry. So if you divide by 2 here, 12 divided by 2 is 6. 6 divided by 2 is 3. Okay, is the statement still true? Is 3 less than 6? Yes, the statement is still true. But what would happen if we multiply both sides by minus 2? So what's 6 times minus 2? It's minus 12. And what's 3 times minus 2? Is minus 6. So don't forget, all of these statements are true so far. So if I times this side by minus 2, I get minus 12. And if I times this side by minus 2, I get minus 6. Now look very carefully here. Is minus 6 less than minus 12? No, it's not. So this statement is actually false. Minus 6 is not less than minus 12. Otherwise, what's more colder, minus 12 or minus 6? Obviously minus 6 is warmer. Okay, if you had £6 debt in the bank, you're better off than having £12 debt in the bank. Okay, so if you look at the number line, number 6 is minus 6 is greater than minus 12. If you look at the number line, minus 6 is greater than minus 12. So this statement is not true, but this statement is saying minus 6 is less than minus 12. So what happened? How comes all these statements were true? So we could do anything. We could add, we could subtract. The statement didn't become false. But as soon as we multiplied both sides by -2, the statement became false. This is a very important rule in inequality that you got to remember. Okay, so what we should have done was we should have changed the inequality sign and made it like this. This is true. So look, the inequality sign stays the same here, stays the same here, stays the same here, stays the same here, but here it's wrong. To make it true, we have to flip the sign over. So instead of being like this, it has to become like this. Okay, so this brings us to a very important inequality rule. If an inequality is multiplied or divided by a negative number, so if you times it by a negative number or you divide by a negative number at any point, the sign must be reversed. So if the sign was like this, the sign will have to become like that. Or if the sign was like this, it will have to become like that. It has to get reversed. Otherwise, inequalities can be treated in the same way as equations. Okay, so you'll see why this rule is so important when we start solving some inequalities problems. So the most important to remember is if you multiply or divide by a negative number, the inequality sign must be reversed. So if it's like that, yes, we change to that. Okay. So question 8, solve these inequalities. Now it might look a bit tricky with the inequality sign, but I would like you to maybe first of all solve this inequality sign pretending or imagining that they were not inequality sign but they were actually just equal sign. So just answer A, 3x plus 4 equals to 10, and for B, 2x minus 5 is equal to 4 minus 3x, and C, x plus 4 is equal to 3x minus 2. So if you start solving these first, you should be able to do these because there's another playlist that we've just done which is solving equations, basic equations. So before you do this topic, you should have done the playlist on solving equations. If you don't understand solving equations, you'll find this difficult. So please try and solve these equations first, then we'll see what to do with these inequalities here. So to solve this inequality here, I'm going to solve this equation here, but instead of having the equality sign, I'm going to just write equals 10. So what's the first thing we do? We have to try and get rid of this plus 4, so we're going to subtract 4 from both sides of the equal sign. So 10 take away 4 is 6. Obviously this plus 4 minus 4 cancels out, leaving with just 3x. And to get the x on its own, I have to divide both sides by 2. So 6 divided by 2 is 3. And here, sorry, I should have divided by 3, sorry. So 6 divided by 3 is 2. So this times 3 and divide 2 cancels out, so x is 2. Let's just check by substitution. So instead of 3 times x, is 3 times 2 is 6. 6 times 4 is 10. So x is equal to 2. It's actually the exact same thing. The answer to this question is actually just x. Then copy this instead of the equals and put 2. So that's the actual answer to this question. So how do you do it? Here's my working out. So can you see I took away 4 from, subtracted 4 from both sides and got 3x is less than 6. Then I divided both sides by 2 and I got x is less than 2. So solving inequalities is exactly the same as solving an equation, but you just have to keep this sign here instead of the equal sign. That's all it is. The only thing you need to remember, there's one important, the important rule is that the sign stays the same unless the inequality is multiplied or divided by a negative number. That's the only thing you have to remember. Otherwise, inequality is exactly the same as solving equations. Solving inequalities is the same as solving equations. You just got to keep the inequality sign in instead of the equal sign. And the inequality sign will flip if you multiply or divide by a negative number. So now that you found that x, the solution is x has to be less than 2. What does that really mean? Well, what that means is we can substitute any number here, any number, so long as it's less than 2, then this inequality sign will always be, or this inequality will always be correct. For example, remember we said x has to be less than 2. If x is 2 or more, then this inequality here will be incorrect. So let's check that out. So what's 3 times 2 add 4? Well, 3 times 2 is 6, add 4 is 10. But remember, our inequality is that it has to be below 10, less than 10. So therefore, 6 add 4 is not less than 10, it's wrong. Which is what we expected because we said x has to be less than 2. So x can't be 2. X has to be any number less than 2. So let's try it now with x is equal to 1. So instead of 3 times x, we're going to write 3 times 1, add 4, and we want the answer to be still less than 10. Well, 3 times 1 is 3. So you can see 3 add 4 is 7, so, and 7 is less than 10. So this time round, the inequality is true, is correct. So can you see, you can now substitute x with any number less than 2, so 1 or less, and this inequality will always be correct. If you put a number which is equal to 2 or more, then the inequality will no longer be correct, as we showed here.